This is a lesson for Principle of Conservation of Energy Part 2. So these are learner's outcome. These are some of prior knowledge. In this lesson, I will require you to know what is kinetic energy and what is gravitational energy. So Principle of Conservation of Energy states that energy cannot be created or destroyed, but only changes from one form to another. So there are two situations for this, a closed system and a non-closed system. So an analogy for a closed system. Assuming in a log hall there are 10 people, and all of them have some money, but if we count them, all of them, the total sum is actually 1,000 at the start. So right now they are free to pass some money to another person for the next 30 seconds. And after 30 seconds, they hold on to whatever amount they have in hand. Of course, they may have a different amount from their starting. Some will have more, some may have less than the starting. Or some even may have the same amount. But if we tally all of them at the end of the 30 seconds, we know that the total amount they all have would still be $1,000. It's no more, no less. In fact, at any point in time during the 30 seconds, the total amount will always be $1,000. It is because no one is allowed to leave or enter into the hall. So applying this to the concept of Principle of Conservation of Energy, the amount of money held by different people is similar to the amount of energy in different forms. And passing money to another person is similar to converting energy to a different form. So energy cannot be created or destroyed is similar to the idea that this $1,000 will always be present in the hall. There's no more than 1,000 because nothing is created. There's also no less than 1,000 because no energy is destroyed. Thus, if the system is closed, you can say that the total energy of the system at the start will always be equal to total energy of the system at the end. Or total energy of the closed system is always constant. Okay, just like the $1,000. Okay, total amount of $1,000 will always be $1,000 throughout the entire 30 seconds. So a non-closed system analogy will be similar, except that right now the hall is no longer locked. People are free to enter or leave the hall. So though we know that the starting amount is $1,000, we could only know the final amount if we know the amount that anyone who enters or leave the hall bring in or bring out. So somebody entered the hall means that the total amount will increase. So it is similar to a positive work done on the system. Or somebody left the hall means that the total amount will decrease. It's similar to negative work done on the system. So if a system is non-closed, you find that it is slightly modified. The total energy at start plus work done on will be equal to the total energy at the end. By looking at the above equation, you can see that if it's positive work done, means that total energy at the end would increase. If this negative work done, means that the total energy at the end would decrease as compared to the start. If you look at it, if it's a closed system, means that actually work done on the system is actually zero. So if this is zero, then you are left with the previous formula, which is that total energy at the start is equal to total energy at the end. So in other words, no energy enters or leaves the system. So if we use a simple pendulum to illustrate, a simple pendulum swinging back and forth is constantly doing a convergent energy between gravitational potential energy and kinetic energy. So you find that currently this object has some gravitational potential energy, and if it swings down, it is actually converting into a kinetic energy and swing and convert back into gravitational potential energy. So a closed system means that it is assumed that there is no air resistance opposing the pendulum while the pendulum is swinging. It is because with air resistance, the air friction will oppose the pendulum motion. And this will create negative work done on the pendulum and drain the energy out of the system. So for simple pendulum, which is a closed system which assumes that there's no air resistance, the total energy of the closed system is constant throughout. And this, when we talk about system, in this case we are talking about the pendulum only. So the total energy of the pendulum is for any point in time is gravitational potential energy plus its kinetic energy. And let's assume that at the bottom over here is considered to be GPE is equal to 0. When the pendulum has an edge, so it has a certain height above this, so it has a gravitational potential energy. And since over here it is stopping, or it has a velocity of 0, the kinetic energy is 0. And it is the maximum height, it means that it has the maximum gravitational potential energy. So the total energy at the edge is equals to just gravitational potential energy as seen by the graph over here. Okay, so you see that the total energy is equivalent to the gravitational potential energy. So when the pendulum is at the bottom, meaning that the pendulum swings. So when the pendulum swings to the bottom, you find that kinetic energy is the maximum and gravitational potential energy is considered to be 0 since it's at a so-called ground level. So you see that again from the graph, okay, the total energy is right now all comprises of kinetic energy. So anywhere else, you'll find that it will comprises of partially kinetic energy and gravitational potential energy. But you notice that kinetic energy plus the gravitational potential energy will always be equivalent to the total energy. So for a simple pendulum with air resistance, the system is considered to be non-closed. So in this case, the equation is total energy at start plus some work done on is equals to total energy at the end. In this case, the air resistance, as mentioned, will create a negative work done on the pendulum. And in this case, the energy is converted to thermal energy in the air. So this is what will happen. As you can see, as the pendulum swings, okay, it will swing slower and slower, or it didn't swing as high, and some of the energy is actually being converted into thermal energy, okay, which is in the air. So you find that it no longer is able to swing as high or move as fast as before. So the total energy of the pendulum at the end will be less than the starting, okay, since there is negative work done. Remember, if this is negative work done, so we'll subtract away from the starting energy, that total energy at the end will be less. And of course, eventually, with this negative work done, the pendulum will come to a stop as all the energy is being drained out by the negative work done. That will be end of this lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.